In this lesson, we're going to be looking at transformed cubics, which is one of the functions that was discussed last lesson. So all the rules for the transformations that was discussed previously apply to cubics. So a cubic function is a function of a polynomial of degree 3. The domain for all cubic functions is all real numbers from negative infinity to positive infinity. Range is the same, all real numbers from negative infinity to positive infinity. As x approaches positive infinity, f of x will approach positive infinity also. And as x approaches negative infinity, f of x will also approach negative infinity. And then where the graph turns from concave down to concave up is called the inflection point. For the parent function, x cubed, the inflection point is at the origin, 0, 0. In this graph, we want to identify how what we're doing to the parent function, cubic function in black, to get the image, the transformed image in blue. So we can see that it is being translated 2 units to the right and 1 unit up. So h will be 2, k will be 1. And we can also see that it's being stretched vertically by a factor of 2. So a is going to be 2. B is where you can either make the a negative or the b negative. I'm going to make the b negative. It's -1 because it's being reflected. You could either say it's being reflected horizontally or reflected vertically. You can only do that for parent functions, the parent function x cubed, because it has rotational symmetry. Again, h is 2 and k is +1. So our equation should be g of x equals a, which is 2, times the quantity 1 over -1 is -1 or negative, and then parenthesis x minus h, which is x minus 2, cubed, and then plus k. K is 1, +1. All right, now we need to identify some of the key features of this cubic function, starting with a. A is the number in front of the parentheses, so it's -1/3. B is, if there were some inner parentheses, then we would have a value for b, the denominator outside of that inner parentheses. We don't have any, so we're just going to put NA, or just 1. And then h is -2, because x minus -2 is x plus 2 is the same thing as x minus -2. So h is -2. And then k is the number at the constant at the very end, which is -5. All right, so the inflection point, since it's being translated 2 units to the left and 5 units down, that would make the inflection point at -2, -5. And then reflection, it is being reflected vertically because a is negative. Or you could put across the x-axis. As far as the vertical compression or stretch, there is no inner parentheses, so there is no vertical compression or stretch. I'm sorry, the vertical compression or stretch is the number outside the outer parentheses, and that's 1/3. So because the number is between 0 and 1, it's being compressed 1/3 units. There is no horizontal compression or stretch because there's no inner parentheses, so we're just going to put NA. Vertical translation, it's being slid 5 units down, so down 5. And horizontal translation is being slid to the left 2 units, so left 2. All right, and in this equation, looks like the same one is, yeah. All right, so in this one we've got for A, negative 1/3. For B, we've got 1. For H, negative 2. Actually, we're just finishing the rest of that example 2. So the domain is going to be all real numbers for all cubic functions. Range is going to be the same, all real numbers, negative infinity to positive infinity. As x approaches positive infinity, f of x is going to approach, now the parent function would approach positive infinity, but this graph is being reflected because a is negative. So instead of approaching positive infinity, it should be negative infinity. And then these two should always be opposites for cubic functions. So if it approaches negative infinity as x approaches positive infinity, then as x approaches negative infinity, it's going to approach positive infinity. So these should always be opposites for cubic functions.